Hello, this is part one of the tutorial on how to create our F4 airplane in Planemaker. I've launched Planemaker 9.0 and we're going to create the wing, the horizontal tail, the vertical tail, the weight and balance, and the control geometry menus. So the first thing we do is click on Standard, choose Wings. This is where we're going to create our wing. The semi-length is along the 25% chord, so the handout shows you how to calculate this based on the b/2 value. We're going to put in a value that's calculated of 23.38. The root chord is 22. The tip chord is 4.8. And the sweep angle is 48.5. So that looks like a wing of our F4 there. We need to move it to its correct position on the fuselage from the datum, so the value for the longitudinal arm is 4.8. Lateral arm is 0 and 0 because we're running the datum right through that. We need to put an aileron on these two sections outboard on the wing, and a roll spoiler, same sections here, and flaps on these inboard stations here. So we're good with the wing. The next thing we're going to do is the horizontal tail. So we click on the horizontal stabiliser tab here. Same thing, we calculate the semi-length, use the root chord and tip chord for this. So we have a semi-length along the 25% chord of 9.9, and the root chord's 8.5, tip chord's 1.8, and we put a sweep on this of 42.8. So there's our horizontal tail, got the sweep, and we need to put the longitudinal arm. We need to scoop this back to where it belongs after the wing. Got 32.13, and we're going to move this up 3.7 into the correct position vertically. So look over here, you can see that it's starting to look like an airplane. We're going to put the instance with elevator because it's an all-moving tail, like that. And we're good with our horizontal stabilizer. So the next thing is, I believe, the vertical tail. So we go to vertical tail here. Enter the semi-length, root chord, tip chord. There we go. Root chord's 14.7. Tip chord's 3.7. And we'll sweep this back so it looks like a nice vertical tail. 63. And notice the dihedral is already set at 90 degrees, which pushes it up to be a vertical tail. The longitudinal arm is 28. Again, this is the distance to the aerodynamic center of each of these items, the wing, the fuselage, or the wing, the vertical tail, and the horizontal tail. And the vertical arm is 5.92. And again, that's the distance up to the aerodynamic center of the vertical tail. We need to put a rudder on here, so we're going to do a full span rudder here. Checking on the recording progress. And I think we're done with our vertical tail here. So the next thing we're going to do is, let me scroll down on my handout here. I'm going to go to the weight and balance menu and enter the values for that. So we're done with the wing. Close this out by clicking on the X here. And there's what our airplane looks like so far, looking good. Go standard, weight and balance. And so we need to tell it where the CG is on this airplane. The CG is, oh, we have to enter this value first before we can enter the forward CG. We have to enter this center value, and then we can enter this value. And we'll give the default aft CG of 14, leave that alone, and we'll move the CG up to its proper location 1 foot above the datum. Our empty weight is 30,000 pounds. We're going to give it 9,000 pounds of fuel. Went a long way there. No JATO jettison weight, no jettisonable load. Cool thing here is if you want to, you can jettison fire retardant, water, or anything else, but we're not going to do that for our airplane. And the max weight on our airplane is going to be 55,000 pounds. So I think we're good there, checking that I clicked everything. And we're going to locate the fuel tanks, going into the tank button here. We're just going to use one tank here. And we're going to put the tank right at the CG, so that as the fuel burns, the CG doesn't shift. So we'll put these values here. So we're right at the CG for our first tank. And we can close this out. That's our weight and balance. And now we want to do the control geometry. Let me double check I haven't missed something here. Okay, we're doing well. Go up to standard. Come down to control geometry on this menu. And here's where we tell it the sizes of the ailerons, rudder, and elevator and how far they can deflect. So we're going to use a 0.24 chord aileron. And you can have the aileron different sizes depending on inboard or outboard. We're going to keep it the same. And the aileron is going to be able to go plus and minus 16 degrees. And here we're going to put in our elevator. And there is no chord ratio because it's an all moving tail, a stabiliser. Let's see, this is 8 here, sorry. So there's more nose up than there is nose down. And then our rudder is a 0.21 chord rudder that can go plus or minus 26 degrees. And we'll put in our spoiler chord ratio. So this is the roll spoiler, and it can go up and down 30 degrees. You can change the input as to the ratio of when that engages or not. We're just going to leave this alone. So we're going to use that value here. And I think we've covered everything on that menu. So that's our control geometry. Notice you can put speed brakes and everything else on here. We're not going to get that fancy. We're not going to do much with the flaps here for right now. Alright, so we can close that down. And there's what our airplane looks like so far. And if we want to save it, we can say save as, and then we stick it in a folder on our airplane. Let's put it in the experimental category, and we'll call it the AE514 demo. Click save. And there's some stuff we still need to fix here, but we're going to do that in the next video. So that's the end of this video for now, and look for part 2 of this video that will talk about the rest of making this airplane.